Hey guys, we are graphing an exponential equation. So you can see here I have x as an exponent, okay? So we're going to graph this. If you've been graphing parabolas, absolute value, things like that, you're probably used to having a parent graph and then just figuring out how to move it around to get the graph you are graphing, right? How many times did I just say graph? I don't know. So we are doing the same thing here. It's just a little different, and let me show you why. So this is kind of my standard equation I go off of, right? The thing that makes this a little different is this b here, okay? In this equation, it's a 2, but it's not always a 2, right? It could be basically any number. So my parent graph changes based on what that number is, okay? So each time we do one of these problems, we are going to figure out what the parent graph looks like before we figure out this graph, okay? Is it a little more work? Yes, but we can do it, okay? So this is similar to other transformations you've probably been doing, where if there is a number out front, in front of this number, it changes my graph a little, right? If this doesn't apply to this problem, but I will link a problem in the corner where it does, okay? And then these numbers, the H and the K, up here and down here, right? They tell me how far I go to the right and left, or up and down. So let's go ahead and just make a note of that really fast before I graph my parent graph, okay? So this plus 4 tells me that my parent graph is going to shift to the left 4, right? Left 4. And the minus 5 on the back tells me my graph is going to shift down 5, okay? So once I am ready for that, that is what my graph is going to do. Okay, now I am going to figure out what my parent graph looks like, okay? When we are doing a parent graph, what we want to do, as with all things in math, there's always more than one way to do things, okay? For this, what we are going to do is we are going to have our parent graph be y equals a times b to the power of x, okay? If you're like, what is this lady talking about? Stick with me, we're going to do it, and I bet you'll be like, oh, that's what she was saying, okay? Now, in this one, my a is technically a 1, right? So we don't need to worry about the a. So what we are going to use as our parent graph, hold on, I'm going to switch colors, is y equals 2 to the power of x, okay? That is going to be my parent graph. So let's go ahead and make a table, see what this graph looks like, okay? So I've got x and y, okay? Now we are going to graph, let's plug in points -1, 0, 1, 2, and 3, okay? So if I plug in -1 here, right, I'm going to get y equals 2 to the power of -1. When I have a negative exponent, I put that in the denominator, right? If you're like, what is she talking about? That's witchcraft. I'll link a video where I explain why this works, okay? So this is going to end up being y equals 1 over 2 to the power of 1, which is just 2, right? So when I plug in -1 for x, I got 1/2 for y, okay? I'm going to plug in 0 for x, and I get y equals 2 to the power of 0. Anything to the power of 0 is 1. Right? Again, if you don't believe me, I'll link a video in the corner explaining that, okay? So when x is 0, y is 1. When I plug in 1, I get 2 to the power of 1, which is just 2, right? Okay. When I plug in 2, I get 2 squared, which 2 times 2 is 4, right? And when I plug in 3, I get 2 to the 3rd power, which 2 times 2 times 2 is 8. Okay, so let's go ahead and plot these points, okay? So I have -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8, okay? So as you can see, this is going to keep getting steeper, right? And it's going to keep getting smaller in this direction, but never actually touch 0. It's going to get closer and closer and closer, but never actually touch it. And then it's going to go up something like this, okay? So that is my parent graph for this equation, okay? That's why I did it in gray. Now I'm going to do the other graph in blue. Isn't that a great idea? I thought it was. Okay, so I'm taking this same graph, I'm just shifting it to the left 4 and down 5. Okay, so I can do it by each point if that is helpful, which that's helpful for me. So I'm going to start here. I'm going to shift to the left 4, 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. Now from here, I can either go here and go to left 4, down 5 again, right? Or I can just see how these points are related and relate them the same way again. Okay, so either way, I'm just going to count my points. 1, 2, 3, 4, down 1, 2, 3, 4, 5. Okay, this one, left 1, 2, 3, 4, down 1, 2, 3, 4, 5. Okay, last one, 1, 2, 3, 4, down 1, 2, 3, 4, 5. I hope you enjoyed listening to me count to 5. Okay, so this is what my new graph looks like. We're going over here and up like that. Okay? All right, I hope this made sense. Okay? If you need some more examples, I will link a playlist for you. Thanks. Bye.